Hello students, let us discuss today's class nomenclature of coordination compounds. Generally for coordination compounds, nomenclature is very important. Why? Because it is very difficult to describe formulas and writing their names when dealing with isomers. Okay, so here let us start. There are some rules to write a formula. So generally Iupac we are going to say Iupac means what? International Union for Applied Chemistry. That one we call it as union. So what is the first rule? Let us see. So here in naming ionic complexes, the cation part is named first followed by anion part. Means positive ions are named first followed by negative ions. Okay, so the number of anions or cations here no need to indicate. So what is the first rule here we are going to discuss? Positive ions. Positive ions are named first followed by negative ions. So means what here? Positive ions are named first followed by negative ions means what? What is the first one? Means what here? The number of anions or cations we should not indicate. For example, I am taking here K4 Fe CN6. Okay, so here we are having two positive ions. So here we are giving first prior to this one. So why we are giving for this one also I'll explain you. Potassium, how many cyanides we are having? 6. Hexa, cyano, ferrate, 2. Okay, so this is the oxidation state. In bracket it will represent oxidation state. So what I have told, what is the first rule? Positive ions are named first followed by negative. So means what? First the positive, then we have to write negative. Again afterwards again the positive you are going to get. So means what here? So the positive means we should not mention how many positive and how many negative are there. Okay. So next one. So when you write coordination pair ligands are named before the metal atom. So means what here? Formula. The metal ion is written first. So coordination pair means what? Which will be representing in the square brackets. That one we call it as coordination pair. So in coordination pair, ligands are named first, then metal atom is last. Okay, so means metal ion is written first here. Means what here? In the beginning ligands have to be named, then the order of the ligand in their alphabetical order we can say. So here what I have told you first. So this is the coordination pair. So first ligand you have to write, then only you have to write this one. So that only we are mentioning here. Within the coordination pair, ligands are named in the beginning. Okay, so first what we have to do? We have to write in the beginning, then we have to follow the order. So means what here? Here I am taking example as Cu NH3 4 SO4. So this square brackets, within the square brackets, so this one we are not including. This is the coordination pair. So within the coordination pair, this is the ligand. So the ligands are named in the beginning. So here what we can say? Tetra amine, copper 2, then we have to write remaining copper 2 sulfate. Okay, so this is the thing we have to write. So what is the next rule here? Prefixes. So means starting we have to denote the number of same ligands which are present in the coordination sphere. So means what here? Complex ions are denoted in parentheses and prefixes by bis, tris, like that. Means di, tri, tetra, it is there, no? Like that we have to write. Okay. So means what here? For anionic complex ions, the name of transition metal ion ternate as 8. For cationic complexes, it is the transition metal is written by oxidation number in Roman numbers at last. Okay. So in case of ligands, so this is the thing we have to write. So what I have told you here, prefixes. So prefixes means starting. Prefixes are used to denote the number of same ligands that are present in the coordination sphere. Means what means here? If there is a 2, we call it as di. For that we call it as bis. Simple ligand. Complex ligand we call it as bis. Okay. So means for example, how many ligands? For 2 ligands, we say it as bis. Okay. For 3 ligands, we say it as tris. For 4 ligands, we say it as tetrakis. So 5 ligands, pentakis. 6 ligands, hexagons. Now let us take example here. CO, NH2, CH2, CH2, NH2 twice, Cl2 and Cl. So this is the compound they have given. So what we will name? So here how many chloride we are having? Total 3 chloride. So here first of all we have to write dichloro. This one we call it as bis. Why? Because the ligand is having total 2. So first you have to write dichloro bis. Bis means ethylene diamine. Ethylene diamine. So cobalt 3 chloride. This is the name. Cobalt 3 chloride. Okay, so this is the name of this. So next one, if you have been taken, what is the next rule? These are the 3 rules. If you have been taken, ligands are named in first of all alphabetical order. What is the next rule? Ligands are named in alphabetical order. So means what here? If you have been taken PT, Cl2, NH3 twice, so we can say that this is a diamine, dichloro, platinum 2 we can say. Okay. So next one, if you have been taken here for anions. For anions, how you will be writing? For anions are denoted by suffix O. Means neutral ligands are denoted by the original names, and for anions it is represented as O. So means what here? 8 it is going to get. For anions it is getting suffix 8. So we have seen ferrocyanate, hexacyanoferrate, yes or no? So plumbate, ferrate. So like that we are getting. So means what here? For negative, for anions we are getting. For example, I am taking here COSCN4 2 minus. So we are getting tetrathiocyano cobaltate 2. So for anions we are getting this one. For cation we can write, for transition metals, For cations, how we are going to get? For cationic complexes and neutral complex, the name of transition metal ion is written as last. Okay, means oxidation number should be in the Roman numbers. At last we are going to write. So means what here? If you have been taken here for cations, CO NH362 plus. So what will be the name here? Hexaamine cobalt 2. Okay, cobalt 2 ion we can write it. So this is the thing we are going to write. So not only this here, so here if suppose coordination compounds is having water molecules, okay, if suppose if there is a ligands where ligand attached to central metal ion, so we can write it as here pentaamine nitrate O cobalt 2 3 chloride. So means for different atoms if it is present, we can write it at different symbols. So bridging ligands, it is going to present mainly two metal ions. It is denoted by prefix mu also. So how we can write? What is the another rule we can say here? For cations this one, for anions this one. In case of ligands, where the ligands attached to central metal atom through different atoms. So what we can say here? In case of ligands, where the ligands attached to central metal ion through different atoms. So means what here? For example, CO, ONO, NH3, 5, Cl2. Okay, so like this if they have been given. So if they have been given like this, then we can write it as, first one we will be writing pentaamine nitrito. Okay, so nitrito cobalt 2 chloride. So this is the way to write. If suppose if coordination compound is having water molecule, so if coordination compound having water of crystallization, then how we are going to write? Tetraaquo dichloro cobalt 3 chloride 2 water, like that we have to write. So what we can say? If coordination compound possess water of crystallization, then how we can write here? So we can write it as like this. That is, example here, if you have been taking CO H2O4 Cl2 Cl dot 2 H2O. So means what here we can write? Tetraaquo dichloro. This one. Next we can write cobalt oxidation state. Next chloride. Next how many water molecules? 2 water. We are having this one. So this is the way to write for these type of compounds. So now let us see some of the examples of Iupac names, how we have to write their names. Okay, so for example, I have been taken CO Cl3 NH3 twice. Okay, so we don't know it is whether it is a neutral molecule or whether it is a cation or whether it is a anion. So how we will be writing? First of all, find oxidation state. For this take X. Here how many molecules we are having? Chlorine 3 into -1. For ammonia you will be getting 2 into 0. There is no charge, 0. So x plus -3 is equals to 0, X is equals to plus 3 for cobalt. So what is the for cobalt oxidation state? 3. So we have to mention in Roman numbers. Okay. So now how we will be writing means here. First of all, we have to write trichloro. Trichloro. Next one, triamine. So trichloro, triamine, cobalt. 3 is the oxidation state. So means what here we can represent. So this is a neutral molecule. Why? Because first what we are writing. First we are writing orderly. That's why we call it as what this one. This is what here neutral molecule. So this one represents neutral molecule. If suppose if you are getting here Cu NH34 plus 2. Okay. So how you are getting, so plus 2 charge is there, so it is a cation, we can identify it is an cationic. So here 4 into 0 is equals to plus 2, which is an X. For copper, X is equals to plus 2. So for copper, what is the oxidation state? Plus 2. So this is the cation. If there is no charge, it is a neutral. If there is a charge, it is a cationic. If there is a minus charge, or first I'll say you how it will be. So here plus 2 we have got. So first what we have to write here for positive charges also, first we have to write this one, tetraamine copper. 2 is the oxidation state. Okay. So for neutral molecules and for coordination compound, for cationic complexes, this is the thing. Coming to for anion, if there is a charge Pt Cl4 minus 2, there is a charge, we can easily identify that it is a anionic. If suppose if there is a K4 PtCl4, okay, so we don't know whether it is a cationic, anionic or neutral. So for this we can write easily what for Pt we are going to get 4 into minus 1 X plus minus 2, X is equals to plus 2 is the for platinum. So you are going to get here for anions, one thing you have to remember what means, at last we are getting suffix 8. So means what? Tetrachloro. Okay. Tetrachloro platinate. We can write it. Platinate 2 we can write. But coming to here, what we have to say, first we have to mention this one. So here also for platinum, there is a, this is 4 into 1 plus X plus 4 into minus 1 is equals to 0. So X is equals to 0. So 0 we are having. So what we can write means here, first we have to mention potassium. Outside the square brackets, whatever it is present. So that one, tetrachloro platinate we can say. So means what? If outside the square bracket starting at prefix any positive element is present, that one starting we have to write, then ligand we have to write, then at last we have to write the this transition metal which is inside the coordination sphere. So this is the way to write, the simplest way to write the anionic, cationic and here for neutral molecules. Okay, this is about Iupac names. So we have to, first of all we have to see what here the symbol of central metal ion is to be indicated, then ligand which is bounded to central metal ion, whether it is anionic, neutral or cationic, we have to write it in the alphabetical order. Then metal ligand and ligands are in square brackets. Then what we have to check, the formula written continuously without spacing. Then if there is a charge outside the bracket, we have to write right side that 8. Okay, so these are the examples we have to mention mainly. So this is about Iupac names. So see what for anionic what we are getting. For anionic at suffix we are getting 8. Means starting we have to write the ligands. How many ligands? 4. That's why we are writing 4 chloro platinum means tetrachloroplatinum. If there is any metal is present outside the, means any element is present positive charge, that one we have to write first, then we have to write ligand, then we have to write platinate. Coming to for this one, first of all we have to find oxidation state for any molecule. For neutral molecules there will be no charge, for cationic there will be a charge present. Okay, this is about IUPAC names and rules. Thank you.